Okay, so let's see if we can get through this time. What you don't know is I've tried to record this about 4 times, and either someone calls me, my wife comes in and wants me to do something, the dog's barking, something, always something. So here we go. So if you'll notice, I've added on a new module called Masonry, and there are tons of how it's made videos in here, and then 4 new readings from LJC, LJC, JLC. And then I've also put some other links here to other different things in concrete. So I kind of wanted to start with that. And I did have it right, LJC? Yeah, well, whatever. So LJC, if you do the readings on the concrete, it will give you tons of stuff there that you can look through and take your time and go through. And it does talk about slump tests a little bit, but I wanted you to see a video on the slump test as well. So look through this and then look through some of those videos and stuff that I've got as well. So you also, yes, I give you another little link here for another thing on slump test, and it kind of explains a little bit more about that as well. Pretty much all the same. Slump tests are done so that we find out how much water is contained in our concrete, and we generally want around 15 to 17% of water in our concrete. We don't want too much. We don't want too much at all, because too much will make it very, very weak. Now, when I talk about putting too little in, there's no such thing as too little. The reason that we add water is to make it workable, so that we can pull it. We can, let me pull up a couple of pictures here. And it's workable. So when you see this down here, especially, we add water so that we can get it to turn into some sort of a liquidated state, so that we can move it about and make it flat. If it's not got water in it, of course, then it's dry and it wouldn't be able to move at all. So we've got to have a workable state. Otherwise, it's useless to us being that form right there, and then we could never finish it. So when we add water, then it becomes workable. But we can set this. Now, this here is what really kind of irks me. This is a no-no. When you put in a post, you put in your concrete mix dry, absolutely dry, and walk away. Don't be adding water to it like this, because it will pull in enough water from the ground and through rain or anything else that it will set up harder, so that when this post eventually comes out, then the concrete will come out with it. I mean, you'll have to tear this thing all down, and it will be so hard that you can't do anything else with it. So when you add water to it, it does weaken it down. Once this is in place, now remember I said you add water to make it workable. Well, heck, we've already got this in the hole. All you got to do is compact it down in there, put your braces up, and walk away. Don't add the water. The water is for no, don't do that. Concrete sets up through means of hydration. That's the chemical process in which concrete hardens. Concrete does not dry. And you've heard, well, wait till the concrete dries. No, concrete does not dry. Concrete hardens. Concrete is a chemical reaction with water. And yes, you do need some water to make the chain reaction, but you don't need this much. You need as little as possible. And in class, I will explain how concrete works a little bit more. But it's basically limestone that creates crystals. And these crystals, when you add water to it, these crystals grow and they interlock with each other, and they interlock with anything that's in or around it, such as gravel, sand. So when you're using concrete, when you're making concrete, concrete is made up of 4 different elements. One being cement. And cement is nothing more than pulverized limestone that has been heated up. All of the impurities are cleaned out of it, and when it's heated up to like 5,000 degrees, and when it does that, the pure limestone will clump together, called clinkers, and these clinkers are then taken and turned into a powder, to a dust. And I do believe that I do have a video. Yes, it is. Right there it is. Cement, how it's made. Watch that video. It's a great video on how it's made. So the second item is gravel. So the term is actually used as large aggregate and small aggregate. So when we want to put in aggregate, large aggregate, we would rather have something like this that has a lot of jagged edges on it. Even the small can be used, but what we don't want to use is smooth rock like that comes out of a river. This is not good. We need something for that concrete to adhere to, or for that cement to adhere to grab onto. So it's pretty much like you're on a slick rock. Okay, so you're climbing a rock, and if it looks like this, you can pretty much climb it. You got handholds and so forth. If it looks like this, you can't do it. You're not going to be able to grab onto it. It's going to be slick and round, so that's not cool. Sand, or fine aggregate. The fine aggregate that we put in, and this is what mason sand looks like, and it's a yellowish tint to it. Whenever you see white sand like this actually has organic material in it. So that's what makes it white. When we have pure sand, pure silica is an actual yellow color. And that's why dunes appear this color here, because it is pretty much pure sand. There's nothing living out here. When we go to the ocean and we're playing out on the beach, then we're going to have all kinds of organic material that's going to get washed up into this, and it's going to mix into it. So this is not good sand to use when we're making concrete. The last thing is water. Again, as little as possible, but the term potable is what comes to mind. You don't want to be using no dirty looking water, nothing like this, in your concrete. Well, that might be okay. If I wanted to find dirty water, I couldn't find dirty water. So dirty water is not cool. Dirty water has organic impurities into it. So this is not what you want to use. So which one would you choose? This one here for making concrete. Don't be choosing this one. This one's got organic material in it, and it would not be good for the cement. So there are several different times that the word concrete is brought up in the North Carolina Residential Building Code. And I'm trying to get to the beginning of this. Retaining walls, foundations we talked about. And in here, basically, if you go up here and just type in concrete, you get to this by hitting Control F. And when you put in the word concrete, you'll see that it appears 396 times within the code. And these are all of the different places in which it's mentioned in there. However, it is mentioned at the beginning up here through what is called your definitions. That's what I was trying to think of. So the definitions, it pulls out concrete and talks about it quite a bit in there. If you Google concrete, you come up with Wikipedia, you'll see that concrete has been used for ages and ages and ages. And one of the things that I want you to pay close attention to here is that it was used by the Roman Empire. All right, so they built things such as the Colosseum. This is the Colosseum. This was made of concrete. Absolutely, it sure was. It was made of concrete, and after the collapse of the Roman Empire, the recipe for concrete was lost. And it wasn't until the 1700s, late 1700s, that a man had reinvented the recipe for it, and it used Portland cement. Now, the term Portland cement means that it basically it came from Isle of Portland in Dorset, England, and that's where it was quarried from. And when the rocks were finished, they looked like the rocks that were surrounding Portland. So that's where the name come from, and that's all basically it is to that. So there's nothing special about Portland cement. It's just what it looks like and where it come from. Now, let's talk about these guys. So these guys actually used a form of concrete as well. So they put all of these blocks together, and they used very thin, watered down limestone to actually make these set level. And when you look through these, these are pretty cool. I mean, you can look through here, and I like how the Mayans and the Egyptians had very similar technologies, lived on very far away continents. However, and even in different time periods, actually, the Egyptian pyramids are way older than the Mayan pyramids. Now, one thing to kind of give you a little bit of useless trivia here. The reason that they aspired to get this slicker finish on a dome type thing is because once it was done, it was polished, and obviously out here in the desert, there's just nothing else around, and there's nothing going to block the sun. So when the sun would hit on this, it would glisten, and it would you could see it for miles and miles and miles and miles and miles. So they didn't just come to this, they actually failed miserably several times. And those are actually shown in smaller ones here. We have stepped pyramids in which the Egyptians used stepped pyramids. So the stepped pyramids look like this. And wait a minute, doesn't it look much like that right there? This is an Egyptian pyramid. This is a Mayan pyramid. Hey, we're going to something here, right? Well, kinda. All right. So they worked at trying to get this to a perfect pyramidal shape. So let's go with fallen pyramid. And I can't spell for nothing. Thank God for Google. So we have the fallen pyramid. Here is a picture of a fallen pyramid. Yeah, we're getting a whole bunch of crap in here. There is several fallen pyramids, but I'm not seeing pictures of them other than this one here. Fallen Egyptian. Pyramids. And not much better. So trust me, there is a couple of fallen pyramids, and that's what they're called, fallen pyramids, because they failed at them. So this is one of the first pyramids that was ever built. Don't know the name of it, stepped pyramid. And then, of course, they went with other stepped pyramids just like this. And then they tried to go to this shape here, and they failed. And that's where the fallen pyramids come in, and I cannot find any pictures in here at all of the fallen pyramid. That aggravates me. But anyway, after the fallen pyramid, they come up with the bent pyramid. And the bent pyramid is basically, they got to moving on this thing, kind of building on it. It's like, wait a minute, if we keep on going this way, we're going to end up with another fallen pyramid. So they changed the design of it, and that led to what pyramids that we know of today, like this. Now, the pyramids actually use pi in their creation, in the way that they finally came up with the right angles in here. So I'm kind of really getting off course here, but nevertheless, they used pie and they used a form of concrete in this when they built them. The Mayan pyramids stayed in a block form, in a step form, and they also used limestone in between these. Now, if the limestone washed away, it was okay because that would settle these big rocks back down onto the rock below it. So the Mayans kept these pyramids. They built them high so that they could get up above the canopy so that the emperors could look out and see their world. But the one thing to note that if a person stood down here, and the reason that they kept the steps, when they stood down here and they called out, notice these different steps, notice all of those steps. When a person calls out here, sound would hit this and come back faster than it would for this one and that one, and of course this one up here. So once they figured this little shape out, they found out that the pyramid sang to them when they called out to it. It was an echo, basically, is what it was, but they didn't know the difference. So that's why the Egyptian pyramids go this way, because they can be seen for miles and miles, and then the Mayan pyramids retained their step shape because of sound. So in concrete, we use it in slab forms. So we've talked about foundations a little bit, but we didn't talk about concrete foundations, and they're poured. We talked about footings. But what I want to do is share with you here a little bit the main two different types of slabs that you're going to see in a house. One is a monolithic slab, which means that the footing and the slab are all poured to one at one time, and then the walls are placed on top of the slab. A floating slab means that, much like what I was showing you in those other drawings in the other video that I was doing, we have a footing, we have a foundation wall, and then the floating slab. So this slab is not connected to this wall whatsoever. Unlike we had here on the supported slab, we did have the one supported slab on one side, but it's not supported on the other side and is able to completely and totally float. Cast in place is a term that we use when using concrete, where we make a form and then we pour inside of it. And that's what they've done here. They've built this huge form and they're pouring this big wall around through here, and they're also pouring some piers in here. So this is known as cast in place. That means that once it's poured in a liquid form, it's not moved from there at all. A type of cast in place is also, we use it in building houses, and that is in the form of an insulated concrete form. And I believe I have Insulated Concrete Form Training Series. This is a great series to look at for learning on how to use these insulated concrete forms. So they're basically just styrofoam Legos, and you put them together, and then you pour the concrete down in. These little plastic tabs hold these two together, and you do have to be careful when you're putting them on. Let's see if this one. No, that's not a good picture. I'm trying to find if sometimes they'll put. Here we go. They'll put these little holders up here. These form holders. Now, even though there's nothing here but styrofoam, we have to pour this at a pour rate. So they're going to pour about 2 feet around the wall, and they're going to continue on around, and they get around to the back of the house. And by the time they get over here to add another 2 feet, this is already hardened. If they were to try to pour this section right here from bottom to top, the weight of the concrete would just tear these forms all to pieces, and they would not be able to withstand the pressure of the weight. So we pour it around, lets it dry a little bit, lets it cure a little bit. Then we get back over to here and we pour a little bit more and we let it cure a little bit. And then, so we work at a slow rate down through here until we get all the way around to the top of the wall. And in that videos, they'll talk about that. So this is also cast in place. Precast. Precast concrete is something that is built on a job site somewhere, in a factory. And one of the things that we use in our building homes is superior walls. And I want you to watch this video on superior walls. Superior walls is a precast system where they build the pieces in a factory. These are steps, and then we take them to the job site and put them into place. These little pipe here, I know you've seen these pipe. These are also precast concrete. Pre-tension concrete. So pre-tension concrete can be both cast in place and precast. So what happens is we get this piece of metal, kind of like a cable, and we pull it between two pieces of tensioning, and we pour concrete. And then when the concrete is done, we let go of this tension, and the concrete wants to bow like this. Now, because of this bow, we can add more weight down on this, and it will last longer and not sag. This is pre-tension or pre-stress, meaning that the tension is put on before you pour it. Post-tension. Like pre-tension, post-tension is very much the same, except the cable is put into a situation like this, and to where we pour the concrete wet, the cable is slacking, and then once it's set, then we pull it tight, and we get that same thing that we get from that we did from the pre-tension. So moving along, the Lengo Viaduct. I'm sure everyone is familiar with the Lengo Viaduct. It is on the side of Grandfather Mountain. Over here in the background, you see Table Rock and Hawksbill and so forth, and my house is right over here somewhere. So the Lengo Viaduct was built with both precast, pre-tension, and post-tension technology. So let me give you an example. Actually, I think it's right down here. Right here. Okay, so these little sections, and you can see this section goes from here to there. These sections, the whole thing here, was cast in place near the job site, and it was cast in place being pre-tensioned across through here and across through here. They're set into place, and then what you can see barely here are these huge cables. Now, see this guy's arm? See this cable? That's how big these things are. They're huge. I've walked through this thing, and if anybody ever wants to go see it sometime or another, let me know, and we'll take us a trip and we'll go down there and see this thing. I will take you inside, but it is illegal. Just remember that. So this thing is set in place. Now notice that these people are standing on this thing. Here is the pillar, the last pillar. And these guys are out here standing on this thing, and it is just free hung out here because of the post-tensioning. Somewhere there is a very sweet video or picture of the Lengo Viaduct being built. There it is. Here is the last pillar, and here's the crane sitting out here putting the next pieces on. So this was so strong. This was so strong that it could support the crane and all these pieces out here. Once they'd stick this piece on, they would stick some new cables on, and they would tension this cable, and then they continued to build it, and it was really, really cool. I got to watch some of this. I was in high school, and here's another one. The last post is here, and this thing is way out here, and it's just amazing how they built this thing. Very amazing. And it's very sweet. It's a very cool place to go to. Uh, it looks like a bridge, basically, but it contours along the sides of this hillside so that the rock from Grandfather Mountain was not disturbed. They use a lot of viaducts over in Europe, Sweden, and so forth to do their roads because it's so much easier to build basically a bridge that goes around all this stuff rather than go in here and try to dynamite all this rock and try to do a lot of earth moving. It's so much easier and it's a little bit better for the environment as well. So when they built this thing, see if I can show you a picture, you kind of can see that there's a cone here. And so this thing sits up here and can teeter back and forth. These are huge rubber pads on either side, and the only thing that holds this bridge in place is that cone. Let's see if I can find another picture of it. I've actually got some pictures myself. Is this going to clear up any? No, probably. Yeah, it does. Yeah, you still can't see it. Here, maybe? You can't see that cone in there still. That cone is just not visible. How about here? No, no better. Still, you can see the rubber pads on either side here. The rubber pad is right there. It's about 6 to 8 inches thick, but then there's a cone here, and that's the only thing that holds this thing in place, its weight. So they have surmised that this would sustain an earthquake of 12 on a Richter scale. So it's really cool. I've been across it several times, and large vehicles. Look here. There's the picture I was looking for. See, there's that cone. That cone is what keeps this thing in place, and it just sits on there. It's not attached. It's not attached. And then these big rubber pads are on here so that this thing can teeter back and forth across this thing. Yeah, I know you guys are going to think twice when you go across this thing again, won't you? But really, it's really cool. It's going to be there forever. It's very, very cool. So again, I would be more than happy to take you guys over there sometime. It'd be great for you guys to go out and see this. It's just a beautiful area. Grandfather Mountain is great if you haven't been there. So that concludes all I've got to talk about today. So we'll leave it at that and just continue on doing your readings and watching your videos.